All right, so this is going to be the pre-lab video for experiment number 16. And so today we're looking at the enthalpy of combustion of vegetable oil. And so kind of what we're going to do is in this lab, we're supposed to take some oil and we're going to basically burn it, right? Combustion is the addition of oxygen, and we're going to turn the hydrocarbon into carbon dioxide and water. So in lab, we would have built what we call a calorimeter, right? So it's actually like a soda can, and inside that soda can, we put some water. Right? And then we kind of build something that looks a little bit like a shield coming on down to help collect the energy, right? And so when we light our candle on fire, right, and it's producing this heat, that heat's going to go up from the candle into the water, and the water's temperature is going to increase. And so all of the heat that we're producing from the candle is going to be gained ideally by the heat of that water. Now that's not really true. Some of that heat is going to get lost out in this direction, right? Some of it's going to go into heating air or heating the calorimeter itself, right? So we're going to lose some of that heat. And so we're going to do kind of two parts in this experiment. For the first part, we're going to do a kind of like a calibration. And so this is during part one, in which we're going to use like a standard candle that we know what its enthalpy of combustion is. And we're going to burn that one, and we're going to see how much heat the water gains. And so we'll use that for our calibration. And then we're going to do soybean oil in part two. And so in the pre-lab video, what we're trying to do today is we're going to talk about the theory behind the experiment. And then in the next video, I'll give you guys the data for what you guys are going to use with it. So the premise of this is that the heat of the candle, whatever we burn, is going to be equal to the heat that's gained by the water. The only difference is that they should be opposite signs. So the candle is going to lose heat. It's going to be a negative value. And so the heat that's gained by the water is going to be the positive version of that. Now, whenever we talk about heat, we want to be thinking about our equation. Q of water is equal to the M, this heat capacity of the water, and it's changing its temperature. Right? So the heat of our water, we can find that if we know the mass of our water. We can look up the heat capacity, and then we're going to take its final temperature minus its initial. Right? So if it's increasing in its temperature, we're going to see a positive change for its delta T. And if it's decreasing, we're going to see a negative change. Right? So for us, our experiment, our water is always going to be gaining heat, so it should be always increasing. So our final temperature is going to be higher than our initial. So as we work through the lab, we're going to be determining that part. Now, for our lab, if we look over, it starts to give us those equations, right? It gives us the equation of what is being released, right? About how we find these Qs. And so it gives us this CP, right? So that CP is our specific heat capacity of water at a constant pressure. Now they give it to us in the form of calories per gram Kelvin. And so we just want to remember that a change of 1 degree Celsius is equal to the change of 1 Kelvin. Right? So if we find our delta T in terms of Celsius, we can still use that same conversion. They're also telling us that 1 calorie is going to be this 1 gram going up 1 Kelvin. And so we want to go ahead and we can use that. But the difference is we're looking for kcal, which is 1 kcal is 1,000 calories. And so we want to keep that in mind as we walk through our equations. Now, the heat of our water is going to come from our candle here. Right? So the heat is what we're releasing over on this side. Oh, here we go. Right, so this is our heat produced. And so if we don't lose too much to the air, then it should be equal to what we make from the candle, just a negative value. And so what we're going to do is we're going to look at the mass that we burn. Yeah. And so that's going to be in grams. We're going to look at the heat that's made by the candle. And we divide those two, we're going to be able to get the kcal per gram of our burned material. And we'll be able to see how much energy our soybean oil releases, right? We can see how it compares with the standard, which is our decanol. Right? So that's kind of the basic premise of it, is that if we look at how much we burn, so this is that mass change. So our final mass minus our initial, that'll tell us how much of the candle we've burned away. And we can use that to figure out this ratio for the amount that we're going to produce. Now, there's just one caveat to it, and that's when we do a calibration. So our calibration is going to allow us to take into account our calibration is going to allow us to find our percent efficiency setup. So then the heat gained by the water, actually let's color coordinate these. The heat gained by the water is going to be equal to the negative, not just of the heat produced, but we're also going to multiply it by the average efficiency as a decimal, because that's going to take into account that fraction that we lose, right? So let's say that our candle produced 300 kcal heat. If only 50% of it, so 0.50, gets converted over, then our water produced, so we need to have a negative sign there. Our water is going to go up by a certain amount. So our heat of our water that is going to increase, we'll move our negative over. So this becomes 300 kcal of heat times 0.50. And so we should see a change of 150 kcal. Okay? And so that's how we're going to use our part 1 to help us with our part 2. Okay? And so that's pretty much it. And so you want to go through and you want to now go over to your lab attendance survey, work your way through that, and then come on back and we'll do our lab data in the next video.